Hi students, today our topic is virtual memory. We know the meaning of virtual memory. Virtual memory is a invisible memory. It is a one integral part of our modern computer architecture. And in order to implement this virtual memory, it needs hardware support. Okay, so this requires the hardware support, and it is present in the unit called the memory management unit, which is built in CPU. So which memory management unit is built in CPU, and this memory management unit is a virtual memory is a part of MMU. Then this virtual memory is referenced by virtual address. Okay, when main memory is how main memory is referred means it is referred by the physical address. Similarly, this virtual memory is referred and referenced by the word called as virtual address. So here this memory management unit is a one unit which has one address translation hardware, and which this hardware, that address translation hardware, automatically translates the virtual addresses into physical address. Okay, so what is the name of that address translation hardware means it is nothing but TLB, translation look aside buffer. Okay, so this TLB is one of the hardware which is present in the MMU unit, which automatically translates the virtual addresses into physical address. There are two virtual memory models are available. What are those means? Private virtual memory, another one is shared virtual memory. So private virtual memory is nothing but one dedicated virtual memory will be assigned for each processor in the system configuration. If your system consists of more than one processor means, in case of private virtual memory model technology, one for each processor, one private virtual memory is allocated, and then address is also referred by its private virtual memory only. Then in case of shared virtual memory model, there is a separate and globally shared virtual memory is there. In that all processor will share its virtual memory. So this is the basic difference between private virtual memory and also shared virtual memory. Private virtual memory, and the examples of private virtual memory models are VAX bar 11, most Unix operating systems. Most of the Unix operating systems are using this private virtual memory model only. So what is the advantage of this private virtual memory model means, when it only consists of small number of private virtual memory for a small processor. So thereby accessing and retrieving the data is more easier, and also speed is also achieved. More speed is also achieved in this private virtual memory model. Then shared virtual memory model. In this model, obviously it combines all virtual memory spaces into a singularly globally shared virtual spaces. So there are two types of that we virtual memory model know. So that is shown in this diagram here. So this left side diagram shows the private virtual memory space in different processors. Here you can able to see the one physical memory. That physical memory is referenced by more than one virtual memory for each processor that is dedicated. For each processor that virtual memory is dedicated. So here the page will be mapped to the globally shared physical memory. In the left side you can able to see the private virtual memory space. In the right side, the second type of virtual memory is globally shared virtual memory. So here like it is same like physical memory, there is a one globally shared virtual memory space is there. So this memory is mapped with the physical memory, so it is shared globally. So the next topic is TLB paging and segmentation. So these three are the important technologies in virtual memory. So let us see one by one. TLB is one of the address translation hardware unit. So what it will do means, it is a one special catch. It is a one special catch. It mainly used to keep the track of recently used transactions. So it is mainly used to keep the track of recently used transaction. Here same like page table in main memory, the TLB also contains some page table entries. Okay, so this page table entries are nothing but those are recently used page table entries. So TLB always contains the page table entries that have been most usually recently used. Okay, then there are two scenarios and situations are introduced here. What are those means? TLB hit and TLB miss. What is meant by TLB hit means if the demanded page is available in TLB page table entry means that situation is called as TLB hit. If the page which is requested or reference is not available in page TLB page means that situation is called as TLB miss. Okay, so TLB hit and TLB miss are the two different scenarios. When the demanded page is available in this TLB page table entry means that situation is called as TLB hit. Immediately that referenced page will be referenced by the processor execution, it will be going on. If the page is not available, if the page is not found in the TLB page means then at that time TLB miss happens. The another name for that situation is called as page fault. Okay, so another name for this situation is called as page fault. So at that time what it happened, that current execution should be suspended and some hardware support should be made to get back the referenced page. So that the time taken to retrieve the page from main memory is called as page load time, page service time. So that we will see in the next slides, right? So this is the one typical example which shows about the TLB hit and TLB miss. So here CPU is nothing but a processor. From that your logical address is given. So the logical address, when you take logical address, there are two fields. One is page table, another one is frame size. So page table is written in red color. If the page is available in that page table entry, TLB bits means that situation is called as TLB hit. Immediately it is given to the physical address for further mapping, or else if the the page table which is demanded is not available means it should that situation is called as page TLB miss. So that time that page or corresponding requested page should be retrieved back from this original physical memory size, that is page map table. So this is another one diagram which shows about the virtual memory with physical memory. Here virtual address is given for mapping function. This mapping function is again given to translation maps and it is converted into physical address. So this is the traversal from virtual memory to physical memory. How it is done means with the help of there are two types of mapping is followed. One is direct mapping, another one is inverted mapping. So there are two types of mapping between the virtual address and physical address is going carried out. One is direct mapping, another one is inverted mapping. Direct mapping follows the one level page table and also multi-level page table, but in case of inverted mapping it follows the associative page table and also inverted page table concept, right? Then this is the another one diagram which shows about the how this virtual address is converted into physical address. Here when you take virtual address, it has three fields: page, block and word. Page is nothing but page table entry in the TLB and it is given to the TLB buffer. If the page is requested page is available means it is given to the, it is converted to the physical address, or else that page should TLB hit miss situation, the requested page should go on search the demanded page and should be retrieved back immediately. Then it will be converted into physical address for further processing. So this is what happening in this virtual memory address and physical memory address. I hope you understand this concept. I will catch you in the next video about next topic. Thank you.